Alright, today we're going to be talking about recursive formula. What is recursive formula and how can it be used to find the terms of a sequence? A recursive formula, we've defined it for you. It defines a term of the formula with previous terms. Okay, it's like if you know one term, you can then determine what the term after it would be, and you can build it like that. Alright, so find the first 5 terms of the sequence defined recursively as follows. And they'll give you a definition in the problem. It's nothing you have to memorize. It's going to be a little different every time. Frequently they will tell you what the first term is, and maybe sometimes even the second term, depending on what the formula is. In this case, my first term, t sub 1, is 1. Okay? And if I'm trying to find the first 5 terms, well, that gives me one of the answers right there. So these are the things that I'm going to want to find. T1, T1, T2, T3, T4, and T5. Now, notice here, this says T sub n, that's the nth term, is 3 times T sub n minus 1. This is really, it's helpful if you kind of add some parentheses in here and think of it as like that, all right? And then it says n cannot equal 1 because, well, it's already defined what T sub 1 is. So it's going to just kind of jump in with the next term after greater than 1, n is 2. So T sub 2 is going to equal, T sub 2 is going to equal 3 times, and now this is T sub n minus 1, so it's going to be 2 minus 1 there, all right, which is 3 times T sub 1. But wait a second, we know T sub 1 from before. That is 1 right here. So that is 3 times 1. And the answer is 3. All right? And now if I want to find T sub 3, it's going to be very similar. It's going to be 3 times T sub 3 minus 1. That's going to be T sub 3. So I'm going to have 3 times, and that's T sub 2. Right? And we already found T sub 2. We found it with the last one to be 3. So it's 3 times 3, which gives me 9, okay? And then T sub 4, 3 times T sub 3. Notice I'm kind of saving myself a little step in here because I know that 4 minus 1 is 3. And you don't need to show all of that work, right? That's really kind of extra. I got ahead of myself a little bit there. It's going to be 3 times, and what T sub 3 is equal to is 9, which is 27. And then T sub 5, the 5th term, is going to be 3 times the 4th term equals 3 times 27, which is, let's see, 51? No, sorry, 670, 81, sorry, 81, there we go. And there's the first 5 terms, okay? And then you may recognize this as a geometric sequence. That's what that is. Next example. Find the first 6 terms of the sequence if T sub n equals n minus 1 over n. Now I threw this one in here. This one is not recursive, okay? This is not recursive. Because you'll notice in my formula, there's nowhere where I have T sub n minus 1 or any of that other stuff. So if I want to know the first term, I simply plug in 1 for all of those n's. Right? So that's going to be 0. The second term is going to be I plug in 2 for all those n's. So 2 minus 1, and that's going to be 1/2, right? And then for the third term, 3 minus 1 over 3, that's 2/3. Right? And then for the fourth, we have 4 minus 1 over 4, which is going to be 3/4. And once you start recognizing the pattern, it's really pretty straightforward. We can already make a prediction. 1/2, 2/3, 3/4. It would make sense that it would be 4/5, which it is. Okay, there we go. I found, I want the first 6 terms. Make sure you're reading your directions. 6 minus 1 over 6 is going to be 5/6. So those are the first 6 terms. You can also list them this way if you like. 0, 1/2, 2/3, 3/4, 4/5, and 5/6. All right, there we go. There are the first 6 terms. Okay, next example. Find the first 4 terms of the sequence. Hang on, there we go. Find the first 4 terms of the sequence with a1 equal to 3, an equal to that, for n greater than or equal to 2. Okay, so again, I'm going to start with a sub 1, which is given. That is just 3. A sub 2 is going to equal 4 times a sub 2 minus 1. And that could be 2 plus 1. It could be n minus 2. It could be n plus 3. And you just have to follow the formula that you're given. So I took this n minus 1 and it became 2 minus 1 for the second term. All right, which is going to be 4 times a sub 1 plus 2. And then you bring that down. 4 times 3 plus 2 is 4 times 3 is 12 plus 2 is 14. 14. All right, a sub 3. 4 times that plus 2, right? Well, what goes in there? A sub 2. 4 times 14 plus 2. 56 plus 2 is 58. I'm finding the first 4 terms here. So a sub 4 is the 4th term. There you go, we're done already, right? It's got to be 4 times the term before, a sub 3 plus 2. So it's 4 times, and what is a sub 3 equal to? Equals 58. So 4 times 58 plus 2. Okay? And then 4 times 58 is going to be 2 carrying 3, 232. So I get 234. Okay, that's the first 4 terms. Next. All right, multiple choice. What is the value of T5 if T sub n is equal to 3 times n plus 2? This is a fairly straightforward kind of question, right? It's T sub 5, so it's 3 times 5 plus 2. Again, not a recursive formula, okay? I've got some just regular formulas in here. These are not recursive. This one is actually arithmetic, and the common difference is 3. All right, so T sub 5 is 3 times 5, which is 15 plus 2, and I get 17. Choice A. There we go. All right. Next, find a formula for the following sequence. Now, this one's a little more complicated, right? And when I look at this, I see that I am adding 3 every time. Okay? So I'm actually going to want to have 3 times n. Right? And if you look at these choices, the first one is the only one that has that choice. So I know it's going up by 3 each time. I'm adding a 3 each time. Well, if I add 3 a number of times, it's the same thing as multiplying by 3. If I add 3 4 times, that's the same thing as 3 times 4. So if I'm adding 3 n times, I need a 3n. All right? And I need to have an initial value here. Like if I want to know my first term, I know T sub 1 has to equal 2. Okay? So what I can do, if I'm not sure, is I can take and evaluate all of these, right? I can just try this one. I can do T sub 1 is 3 times 1 minus 1. Right? And that's going to give me, that gives me 2, which is what I want. And I just check a couple more on it. 3 times 2 minus 1 is 6 minus 1, which is 5. Looks good so far. T3, 3 times 3 minus 1 is 9, minus 1 is 8. And that is correct. That is going to be the right formula. All right? Now, if I try these ones here, right, T1 is 3 times 1 minus 1, which gives me 0. Is that what T1 is? Does T1 equal 0? Does T1 equal 0? No. So it's not that formula. All right? And then T1 equals 2 times 1. That's 2. Okay, wait a second. This one seems to be working. Try T sub 2. 2 times 2. That's 4. Is that what T sub 2 equals? No, so I can eliminate that choice. Okay, so this is one of the ways that you can do it. And it would follow with D. D will eliminate itself as well. Okay? It doesn't even work for the first term. All right, what is the sum of the next two terms in the sequence? All right, so I have -3, 0, 4, 9, 15. All right, and it says what is the sum of the next two terms? So when I'm looking at this problem, I'm trying to decide, right, has it got a common difference? What's happening here? You know, I need to kind of be able to figure out the pattern. Or what's going on, right? It's almost like I want to come up with a recursive formula. All right, I don't think I multiply, because this would be multiplying by 0, and then anything you multiply by 0 is going to give you 0. So it's not going to be a multiply one. I think of it like it's probably adding here. Like to get from here to here, I add 3. And to get from here to here, I add like 4. And from there to there, I add 5. And then I add 6. Right? And I think you can predict the pattern and see what will it be to get to that next term, and then to the next term after that. Well, I'm going to have to add 7. All right? Well, 15 plus 7 is going to give you 22. And then what am I adding to that? Probably 8, right? All right, and then it wants to know the sum of the next two terms. So I just need to know what 22 plus 30 is. All right, which comes out to be 52 is the sum of the next two terms. If I were to try to write a recursive formula for this, how do I get the number? How do I get, how would I get 9? Well, I would take 4 and I would add 5 to it, right? And because 9 equals 4 plus 5. All right, well, let's see, that's a sub 1, 2, 3, 4. That's a sub 4. All right, a sub 4 is actually equal to a sub 3 plus 5. All right, well, and what is 5 in terms of 4? That's really 4 plus 1, right? A sub 4 is equal to a sub 3 plus 4 plus 1. See that? Well, okay, let's generalize that now. A sub n is equal to a sub n minus 1 plus n plus 1. And you'll see, well, I'll try and check and see if that's going to work, right? This was the first, second, third, fourth term, right? Let's see if I can get 15 for a sub 5 using this formula. So a sub 5 is a sub 4 plus 5 plus 1, which is going to be give me a 6, right? A sub 4 is 9 plus 6, and that gives me the 15 that I want. So coming up with the actual recursive formula is a little bit more difficult. All right, this again is like you either have to be clever or patient, right? And either one will work. If you're clever, you can come up with the recursive formula and then be able to go from there. All right, good luck. Thanks.